senior developers get more productive, but junior developers get more dangerous.
Imagine that a whole bunch of these LLMs are talking to one another. They're going to be very much in agreement about a lot.
The difference between a calculator and AI is that AI will give you a different answer every time.
You need to involve something predictable in there. So something that will predictably point out, this is not good.
When I'm generating, 3 million lines of code in a week, to have a human in the loop, that will be quite challenging.
Hi, welcome to the Signal Podcast, the monthly podcast where we turn IT complexity into business clarity. My name is Werner Heijstek, I'm your host, and today I'm joined by Luc Brands, the CEO of the Software Improvement Group.
Thank you.
Welcome, Luc.
Thank you for having me.
Let me just open with asking, and you spend quite a lot of time with clients, quite a lot of time outside.
Mm-hmm.
What I see outside is that there's a bit of a confusion about agentic AI and just using AI as a sort of a chatbot. Is that something you recognize, that you also see?
Well, there's indeed a lot of confusion because there's so much development. If you don't pay attention for 3 months, then there's totally different capabilities. Things that weren't working a year ago are actually in production right now. So an agentic AI is a relatively new development. So many organizations are experimenting with AI and starting to experiment with agentic AI with very interesting results.
But when you see them talk about agentic, it sometimes seems like they use this as a synonym. So we do something with AI, and agentic AI is just yet another way of talking about using an LLM in your day-to-day work, like using Copilot in your word processor, for example.
Exactly, and I think there's a lot of experimentation going on. There's a few front runners that have, or at least claim, great results, but there's a lot of people still trying to figure out what is working, what is not working. And the majority of the organizations in the world are yet finding out what this great technology is going to bring to them.
And in your experience, do you hear a lot of people talking about being satisfied with the degree of results that they're getting with their AI efforts?
That depends. So if they're talking about selling themselves or in a marketing fashion, they might be quite a lot more positive than when you look inside, where people are still in the experimentation phase, do see some level of productivity rising. Some say 4%, some say 15%, occasionally 20%. But like in some of the marketing outings, you might see 70%, but those are hard to substantiate claims, I would say.
This is something in a publication that we recently made, the AI Boardroom Gap. We there cite a study that Stanford did, where they found that the larger a system gets, the less productivity gains you actually get from using LLMs.
Yeah.
Do you ever see anything by means of numbers that you can, and not just the numbers that are claimed, but actually results?
Yes, but limited and rarely for the entire process.
Yeah.
And so what people tend to do is say, I produce so much more code. But that's only one aspect. There's the writing of the specifications of the needs, which needs to get a lot more attention, and agentic AI can also play a role in that. There's the testing, there's the deployment, and especially in regulated industries, it's not as simple as just produce some code. It's a lot more complex than that.
And is there some kind of pattern that you see there? Is there uniformity in organizations? Some looking a bit broader, some focusing more on specific tasks.
Yes, but I think it's with all new technologies. There's front runners, there's laggards, there's people that are cynics that say, let's first see others have results and we'll maybe pick it up. There's people say you cannot use AI in the development of these specific systems, and others are going all in. So in all new technologies, then you see the divide getting bigger. In maybe 5 or 10 years, people will be much closer. Some of the front runners will be maybe tracking back a bit, and some of the laggers will maybe have disappeared or have pulled closer to the front runners. But I think it's pretty normal in all technologies. It also was true when people started to adopt cloud. There was some front runners, and there was some people who said, let's keep everything on premise. And then the front runners made some mistakes in putting too much stuff immediately in the cloud, spending way too much, and then backtracking a bit and making things way more productive. Similarly, but at a much higher pace, is happening with AI. We cannot underestimate the impact.
You said in some organizations it's not allowed to use LLMs or agentic AI for development. I think what I see a lot is that it still happens.
Definitely.
And isn't AI an example, AI in a broader sense, in organizations of something where the disconnect between what leadership thinks and wants is very disconnected from what's actually happening on the work floor?
Yes, but in two directions. One part is that typically the front-runner organizations are pushing AI, use it everywhere, and then maybe the reality is slightly slower than leadership might hope, and vice versa. In organizations that say you cannot use it or we don't endorse it yet, people left and right are creating stuff using all sorts of systems that they bring themselves, that they use themselves because the threshold is really low. So it's actually an effect that works on both ends, and both isn't good. So that's why we really advocate AI visibility. You need to know where it's being used, where you are using AI components, not only for regulatory reasons, but also for reputation reasons, for quality reasons, for all sorts of risk-related stuff. You need to know where that is happening, and you need to know what are you spending on it, and is it giving me the results that I hope they will get. And the promise is it will boost productivity. I think that promise will be definitely true. Maybe not as extreme as some claims are, but definitely more than many organizations get today. But for that, you need to know what you're doing. Measuring or doing something without measuring will never give you any results.
No, so you're specifically talking about having insight on what is happening, but you also hinted at output. Returns on actually, you said productivity, which is always a bit of a difficult term in software development and in IT in general. What do you think are good approximations of that? That are not necessarily super detailed, like how many lines are being created, but on a high level, what would be an interesting collection of KPIs or metrics that would give you a feel of positive outcomes of investments in AI?
Well, it's never one thing. Specifically on productivity, it's really dangerous to just use the lines of code thing, because there's much more to it. Is it giving you more features? But you also need to look at the quality and security metrics. If my quality is going down tremendously, but I'm producing more, then I have maybe a short-term effect, but my long-term effect will be disastrous, because AI is like humans. They can maintain code, but when code is super complex, it will also be super complex to maintain it.
As CEO, why is that important to you? These are very technical details.
Well, I think
if it works, it works. Is my point.
Exactly, and I think many CEOs and business leaders will have that point of view. Well, it works. If you just talk about maintainability to a CEO, would say, okay, why would I care? But if you say your costs are going up 30% in the next 3 years, then you do get attention. You should get attention.
Because it's that 30%, right? It's quality, it's not 3%. Even that would be a lot, by the way, on many budgets, but it is really that amount of...
It's significant. If you don't control it, it's like many organizations have moved away from using COBOL for very good reasons. But if we're creating tomorrow's COBOL in a different language, but with the same cost, nobody's going to be happy.
Yeah,
except for the companies selling tokens, maybe.
Yeah. There were a couple of major experiments recently. So one's Fast Render, which was the most futuristic of all of them, where a swarm of agents built a web rendering engine, which is a notoriously hard thing to do. There are only a few out there that are being used, and almost nobody's making an attempt to make another one. So a swarm of agents did. And that's the most, no human involved. Just, let a collection of agents do their thing, and they'll tell you when they're done. That was one system we looked at. We looked at two others. So the other one was a C compiler that was built with a person, with a whole team of agents. So not quite a swarm, but there was some collaboration. And then there was OpenClaw, which is the sort of personal AI agent that people are using at scale, which were used in a more traditional sense. So humans with of course, with the help of LLMs. And the differences in quality are really staggering. It's like there's a really big... So if there's a human in the loop, you get much better systems. That's the summary. So something like fast render, if you look at the maintainability, which is the degree to which you can make changes to that system as a human or even an AI later, is just very low. And the architecture, so the complexity of how the components of the system collaborate, is just really poorly built compared to what you would expect.
But people would maybe argue, well, if agents can create it, they can also recreate it.
Yeah.
So if there's a bug in it, just recreate it and you're done.
Yes.
But that's where we feel that there's a bit of a mismatch also financially.
Yeah, so the two key points are, first of all, it was very expensive. I think it was 10 to 20 trillion tokens, which is, depending on the type of token, you're talking millions and maybe even over $10 million to just build a system like that, which is in a week, which is not something you do every week.
Hopefully.
Only very few organizations can do that. And then just remember, fast render didn't work. Right, so then you still don't have a working system. You still need to spend more to actually finish that with humans.
Which will be difficult to fix in a one-star system.
What's interesting about these LLMs is that they're trained on a lot of code. Some might say all the code. Everything that's available online, they have been trained on that. So by definition, that's market average. That is what you find on average in the market. At SIG, benchmark a lot, so we know market average is not necessarily great. It's just what you see on the market on average. So that's completely full with vulnerabilities, with suboptimal code. By definition, that's what they create for you if you ask them. So they immediately create legacy code, and that's also what you saw in the example of fast
very
render.
rapidly.
Very rapidly. So it's an impressively productive way of creating a legacy system, and that's exactly what happened.
Yeah. So on that fast render example that you're mentioning, still it's quite impressive what's been done, because making a browser in a week, it's not something that has been done.
It's hard to exaggerate how hard it is to write a web render engine. So most browsers have the same rendering engine as Chrome. So companies like Google or the Mozilla is the other one, and the third one that's still mature web render is Safari's engine. Those are the only three. The rest is either really old or hobby project. It's seen as almost impossible, and it's so hard that nobody attempts it. So the fact that fast render got very close, because it was very close to actually doing what it had to do. There are all types of caveats and details, but it's really impressive that they got to that point. Yeah.
So in a week, producing a couple of million lines of code is, from a productivity point of view, in one point, very impressive.
Yes.
But from a financial point of view, it's almost equivalent to 100 people generating that code, and it's equally expensive almost.
Yes.
It's so from that productivity point of view, the difference isn't that big. And if you then think, well, I need to maintain it next year, then, and this is an element that's sometimes forgotten, because that it's so impressive that you can generate a couple of million lines of code in an almost working system in a week. That all of the rest is almost forgotten. We'll fix that, or there will be a new version. Can you maybe share some thoughts on, well, in half a year there will be a more intelligent version that will be giving us even better code?
It might become slightly better, but what you in the end have, so agentic, the idea behind agentic is that there's a set of systems that together collaborate, and they can do that really, really fast. I think what's sometimes being underestimated is, when you talk to ChatGPT and you ask it a question, it's very sweet and very kind and very forgiving. And imagine that a whole bunch of these LLMs are talking to one another. They're going to be very much in agreement about a lot. So if one LLM asks another, is there a security vulnerability in the code that I've just created? Then that LLM might say, oh yes, there is one, and there's one here, and then generate more code with more vulnerabilities. And then the other one says, well, this is great. So there's an unpredictability to LLMs by definition, by how they're constructed in what they say.
I think there's some research that points out that agentic AI and AI is not necessarily very strong on security.
Yeah, so there's lots of anecdotal evidence, but we also looked at the actual data. We published the AI boardroom gap, and what you see there, it's about a factor 2. So there's 2 times more security vulnerabilities to be expected if your code is generated and you don't actually find those vulnerabilities and address them. That's quite a lot.
That's quite significant.
Yes, because all of these might be individual security incidents in their own right.
Yeah.
You need to involve something predictable in there. So something that will predictably point out this is not good.
Yeah. So which today would be the human in the loop story.
Yes.
But when I'm generating, 3 million lines of code in a week, to have a human in the loop, that will be quite challenging.
Yes.
Because you will need many people or people who just glance over it and have no idea what they're looking at.
No, that will go too fast. So you need a system. You need something that predictably has an opinion on certain quality aspects of what you're currently building. That is what you need.
Yeah. So that's why we're using Sigrid in the loop, human in control.
Yes.
So you do want a human in control, but you do want a system that do very rigidly and deterministically, to use that term, check rather than have a potentially hallucinating system. And agentic, you have many systems that together could be hallucinating a bit or a lot, or you don't know. And that's why we feel you need to have a system like Sigrid in the loop to stay in control. So how would people go about if you would deploy that in reality, according to you?
So I think one of the key things about quality is that you do not want to completely optimize it. You need to be, so quality is very broad. Security is formally also a quality aspect. A perfect security, a perfect maintainability, performance is extremely expensive. That might be something where AI might help, where in the future, as it gets better, that might become cheaper. But what you need to make decisions on, okay, what level of quality do I want for my particular system or set of systems? What is realistic? What is attainable? And then you want to have something as close to as a developer, to your editor as possible. Yeah. So you want to ask, and this is a basic use. So you want to ask an LLM can generate a function, and what you want is before you get that function in front of you, like dear Werner, here's a solution in Java or whatever you're using. You want that to be sent to a deterministic system, like a predictable system like Sigrid, and Sigrid will then say, sorry, dear LLM, but this has some vulnerabilities or this has some problems. Yeah. And you want them to interact until they end up with something that you can start from. So before you even begin making your own edits or your own changes, you want something that is reliably good.
Yeah. So now this then leads to another question where, because you need somebody, that human in the loop or human in control needs to have certain knowledge. Yeah. And I sometimes say senior developers get more productive, but junior developers get more dangerous. Yeah. Because they don't know they haven't got the experience yet. Now, this also creates a problem in 10 years because we're not really educating junior developers anymore. Some of our clients say you need to be programming. You can't use AI, certainly as a junior, but all the juniors are being educated using it, and for good reasons, because it's super productive, super helpful. How would you go about that skill gap thing that might occur in an organization?
Yeah, that's a very hard question. The boring answer and the real answer is that you need to have a balance there. You need to be able to ensure that your skills don't atrophy. I see it with, as I teach at Leiden University, and I see there that pretty capable students still rely a lot on what's being generated for them because they're a bit insecure about, maybe that's then better. Yeah. So and a senior developer knows where there's something, and I think that's the difference where you still retain the skill to be able to do that. I think if you look back at the experiments that we talked about, I think on the one hand you had fast render, which is all out. It's just a test. What happens if we? What might the future look like if it's only AI? I think by now we can say that that has too many downsides. Then you have the other end of the spectrum where, and you have that in some teams where they not invented here. We don't use this. I don't have time to look at it. We still do everything by hand, which is probably a waste. Yeah. So you as an organization, you cannot afford to have many teams like that. Yeah. So the answer is somewhere in the middle, where you try to get as much productivity gains as possible while retaining control. And there are different tricks and approaches to use for that. And I think to answer your question about skills, you need also, as a developer, not only become an orchestrator or a conductor. You need to also have your hands in the code. But I don't know exactly how much and when. I think time will tell. This is hard to...
Well, it is one of the key reasons why we did develop Astrid.
So I heard you talk about Sigrid. I heard you talk about Astrid. Can you perhaps explain a bit more about what these systems, these platforms do?
Sigrid is a platform that at scale helps you to build better software. While we also created Sigrid's sister, Astrid, who's on the people side. So we understand that if you look at people, process, technology, then technology and the process around things like productivity is super important. But if you do not look at the people skills, then at some point you will lag behind. I think it's important to pay attention there, because things are going that fast that we need to be careful that in 10 years' time everything needs to happen agentically, but the quality will go down tremendously.
Do you see that with Astrid already? When you measure skills, do you already see a difference? Is that something that...
I think that's too soon to tell.
Okay.
You would you would see when you look broader in society that certain skills are getting less, like reading skills, calculation skills are getting less. I sometimes give the example when I see the mathematics books from my grandparents, what they had at the primary education, and I see what I had at the time, there's already an enormous difference. If I look at what my children are, the difference is enormous. We have calculators, so we can very easily calculate. And you can think, well, there's an equivalent with AI, but the difference between a calculator and AI is that AI will give you a different answer every time.
Yeah.
Because that's a strength, that it's potentially hallucinating. There's that statistical element in it. There's no such thing in calculators. If I calculate 13 times 73, every time the same number comes out. So I can't trust it. You cannot 100% trust. You shouldn't. And that's, again, it's also the strength. It's not a calculator.
There is a parallel with the calculator, though. You might know from a function that there should be a negative number, and if it doesn't come, then I probably made a mistake in the...
Exactly.
So there's maybe the equivalent of being a senior developer, where you go, this can't be right. There's something here.
You need to have.
You need to have that skill set. You need to have that.
You need to have that understanding. Yeah. Which is why we really want to ask for. Know what you're doing. That's this AI visibility thing that I touched on in the beginning. AI visibility is key for what you're doing, because then you can start measuring. You can if you want to improve stuff, you need to measure it, and not only what comes out of it, but also in a broader sense. So from a productivity point of view, different elements, financially, speed, all of those things. But also quality-related stuff, security-related things, and we don't want to be that organization who always says, "Oh, be careful because things will happen." Again, the biggest risk of AI is not using it. If you're not using it, you will be lagging behind, because it will give you all sorts of advantages with your products, with your capabilities. We're using it ourselves enormously in our platform, but also in our internal processes. And that is making a difference, but you need to do it carefully, because otherwise you will make a mess. That's
so. But imagine I'm a CTO of a large corporation. I have 20 or 50 development teams, and I've recently acquired a license from from Anthropic and rolled it out.
Yeah.
And how do I now? What is a step to get more control over the effects of that?
Well, first of all, you will probably notice that some people are using Claude and other people are using Cursor or Windsurf or whatever, because they have their own private. Depending on the organization, if there's very strong central control, then that might be more limited. So first of all, you need to get policies in place for what can you use, where, when can you use it, and for that you need that visibility. Are you using AI in code generation, agentically, or in more, I would almost say, traditional ways, which is hard to say.
That's how fast we go.
Exactly.
Just the classical way of...
Exactly. But so that's one element in code generation, but it's also necessary to know where you're using AI type systems, not only LLMs, but also more traditional stuff that's been around, because that's also regulated, and you need to have the controls on your model management, on your security, because security in those parts is very, very different. So you need to prevent AI sprawl, so popping up left and right. We recently did this analysis for one of our clients where it was in more than 100 systems across the organization that some element of AI was being used. It is measurable, and you need to get a grip on that. And not to put brakes on it, but to be sure that you're doing the right stuff, and you educate teams on the good things and the bad things, and monitor quality, monitor outcome, monitor productivity, because you will be spending an awful lot on tokens or on licenses or whatever way. Those costs will not go down because all of these companies are now at a loss. Yeah. Prices will go up. That's perfectly normal, and not to be surprised about in the future. So you need to manage that. In your example of fast render, when that would be costing over 10 million in tokens, it's a great result from a research point of view. But if you would do this in production, you would have a very quickly you would have a system that doesn't work and will be very expensive to maintain. So it requires real visibility. What you measure tends to improve, as the famous saying goes. And that's more than true here, because things are going so fast.
Yeah. And how... so maybe we can delve a little bit into the actual agentic part of it. We talked about the traditional or classic use of... and maybe also you hinted at using this broader than just in code.
Yeah.
So what are other aspects, and if possible, agentically, that you around code, this in a broader business context, but in IT, that you see this being used for, or that you see as potential that perhaps organizations are not yet realizing?
Well, I think many organizations do realize that, for instance, writing specifications, checking specifications on completeness, and things like, is it ambiguous? Is it clear? When you do you write an epic and a development team needs to work on that for several months, and it's just a few words, then you can't be surprised that this goes back and forth many times. That's something you can increase quality tremendously. In testing,
and you can measure, by the way, your previous example. This is something you can actually
you can measure that. So it's in the start of the process. It's documentation, it's testing, it's unit testing, deployment. I think across the software development lifecycle, you can use elements either in a one-off part where there's a human totally in control and just uses it for a specific task, maybe to write a unit test, or to write a specific use case test, or agentically, where you have more of those elements working together, again, with something in the loop, like Sigrid, to check.
Thank you very much, Luc. As usual, we will be here next month. All the previous episodes of the past months you can also find on our channel. Hope to see you next time.